In this video, we're going to go through two-step conversions. The essential question that we're going to answer is how can we use molar mass and Avogadro's number to convert between grams, moles, and particles. So in the previous lesson, we looked at one-step conversions. So with a one-step conversion, we were converting between mass or grams and moles or particles and moles. Now, we don't have a direct way to convert from mass to particles. So we're going to use moles as our intermediary. So just think about if you had some, I don't know, old video games, perhaps, that you wanted to get rid of. And you wanted to get a new video game. To go from your old video games to the new video game, you can't just take those games and give them to the clerk at Walmart or GameStop and they're going to hand you the new game. You have to first convert those games into dollars and then use those dollars to buy the new game. Moles are kind of like the same thing. It's a common unit in chemistry that we can use to convert between things. So let's look at this example. It says how many grams of sodium chloride are in 2.4 times 10 to the 23rd molecules. So again, we don't have a direct way to go from molecules to grams. That doesn't exist. But we do have a way to go from molecules to moles, and then from moles to grams. So we're going to need two steps here. We always start by writing out our given number. In this case, that is 2.4 times 10 to the 23 molecules of NaCl. And we're going to need two steps here. Now, rather than doing two separate one-step conversions, we're going to do them at the same time. So we're going to set up two conversion factors back to back. First, let's go from molecules to moles. So we know there are 6.02 times 10 to the 23rd molecules of NaCl in 1 mole of NaCl. Now, if we cancel out our units here, we can also cancel out our power because they're both times 10 to the 23rd. So now we're in units of moles. Now we're going to go from moles to grams. So again, we always want to make sure our units are the same, diagonal from upper left to lower right. So for every 1 mole of NaCl, we're going to use its molar mass. So again, if you don't know how to find molar mass, go watch the video that I recorded on molar mass. So the molar mass of NaCl is 58.44 grams of NaCl. And again, let's cancel out our units. Okay, so that's it. Now, putting this in your calculator is a little tricky. So we have 3 different things, and they're all being, it looks like, multiplied together. So let's go through the calculation. So to do these first two numbers, 2.4 times 1 over 6.02, that's the same as division. So when I enter this in my calculator, it's going to be 2.4 divided by 6.02. And then for my last calculation, I'm multiplying 58.44 over 1. Any number over 1 is just that number. So I'm going to multiply by 58.44. When I plug that into my calculator, I get 23.2906. We always want to round to our given number. So that's 2 sig figs. So we're going to round our final answer to 2 sig figs. So that would just be 23 And my units that I'm left with are grams of NaCl. Okay, so there's our first example here. Let's move on to our next one. This time we're given grams. So it says how many molecules of NaOH are in 37 grams of NaOH. So we always start with the given, which is going to be 37 grams. Now, just like in the previous problem, we do not have a direct way to go from mass to particles. So we are going to first convert to moles, and then I can go to molecules. So we're going to need two conversions, and we're going to set these up back to back. And I'm not sure if I said this before, but another reason why we're doing these back to back is because we don't want to round in between. So if I did my first step here and rounded the number, and then use the rounded number for that second step, my answer is going to be really off because I've rounded now twice. So we avoid rounding until that final step, and it's going to make our answer much more accurate. Again, going from grams to moles, we're going to use the molar mass. So I've already calculated that. That is 40 grams of NaOH. And again, if you are listening to me and you're hearing me say molar mass and you have no idea what that is, you should go watch my video on molar mass. All right, so let's cancel out our units. So my grams are going to cancel. And now I'm left with units of moles. So now that I'm in moles, we're going to convert to molecules. So for every 1 mole of NaOH, I have 6.02 times 10 to the 23rd molecules of NaOH. And let's cancel out our units. All right. There's our setup. Let's go through how to put this in your calculator. So for our first calculation, just like in the previous example, I'm going to divide. So 1 over something is going to be the same as dividing. So it's going to be 37. Oops, I said divide, but I wrote multiply. 37 divided by 40. That'll be my first calculation. And then 6.02 times 10 to the 23rd is in the numerator. So we're going to multiply. So times 6.02. We're going to use that E button on our calculator. That E button, remember, is the same as times 10 and then caret. So whatever number comes after that is our exponent. When I put this into my calculator, I get 5.6. 5.57035 E 23. That E is times 10. So we'll come back to that in a second. But we want to round our answer to the appropriate number of sig figs. There were 2 significant figures in our given. So we want to round our final answer to 2 significant figures. So this will be 5.6. And we want to make sure we don't leave off our times 10. So this is going to be times 10 to the 23rd. And this is going to be molecules of NaOH. All right, let's do one more problem. It says, how many grams of carbon are in 5.32 times 10 to the 23rd? So this would be a good spot to pause the video and try doing this problem on your own. We've done 2 examples, one going from molecules to grams, one going from grams to molecules. Let's try doing this one on your own. So pause the video, try doing this problem on your own. I'm going to pause for a second. All right, so I'm going to assume that you've tried this problem on your own, or you're just going to keep letting the video play. YOLO. All right, so let's go through this. We start with our given. So 5.32 times 10 to the 23rd atoms of carbon. we're going to grams. We don't have a direct way to go from atoms to grams, so we have to convert to moles first. So I'm going to need 2 steps here. Our first step, we're going to go from atoms to moles. So there are 6.02 times 10 to the 23rd atoms of carbon in 1 mole of carbon. Oops. How did I do that? Atoms of carbon in 1 mole of carbon. Okay, so let's cancel out our units. And we're lucky because we have times 10 to the 23rd, so I can cancel that out. It makes our life a little bit easier. And now we're going to convert from moles to grams. So for every 1 mole of carbon, I can just look on the periodic table, and carbon is 12.01 grams. So my units here are going to cancel. So when I put this in my calculator, it's going to be 5.32. This number is in the denominator, so I'm going to divide by 6.02. And then I'm going to multiply by 12.01. So I put that in my calculator. I get 10.6099. I want to round to the sig figs in my given. This time it's 3 significant figures. So if I round that to 3 significant figures, I get 10.6, and my units that I'm left with are grams of carbon. All right. Those were 2-step conversions. Guess what's next? 3-step conversions.